All right, let's talk about one of the coolest, most intuitive ideas in all of machine learning, the decision tree. And here's the thing, you might not even realize it, but you're already an expert. You use them every single day. We're going to break down exactly how computers take that same logic you use and turn it into some seriously smart predictions. I mean, seriously, believe it or not, your brain is basically a decision tree building machine. Every single time you have to weigh a few options to get to some kind of conclusion, you're basically running a little mental algorithm. And it follows the exact same logic we're going to explore right now. Okay, so check this out. It's a flowchart for picking a new language to learn. You start at the top with a pretty simple question, right? Do I want something useful or something cool? And depending on your answer, you go down a totally different path to the next question, maybe something like easy or hard. And you just keep going until, bam, you land on a final recommendation. That right there, that's a decision tree. It's that simple. Or, hey, what about this one? Finding the perfect pet. The first question is, do you want a pet to love and care for? Your answer sends you down one branch or another, and it just keeps narrowing down the choices until you find your perfect little companion, whether that ends up being a cat, a dog, or, even a rock. The logic is exactly the same. And this one might be my personal favorite. Even choosing the perfect emoji can be a decision tree. See? These flowcharts, they're not just for fun. They perfectly capture the core idea. So now let's see how a computer takes this very same concept and uses it with actual data. Okay, so let's get a little more formal now. Let's build that bridge from these everyday examples to how data scientists actually use this tool to make some incredible predictions. So what is it, really? At its heart, a decision tree is just a model that acts like a flowchart. You give it some data, it asks a bunch of simple questions, and then it gives you an answer. And the name is pretty literal. It actually looks like an upside-down tree. You've got the root at the very top, and all the branches spread out downwards. Here's a super classic example from machine learning. The goal here is simple. Predict whether or not a customer is going to buy a computer. So the tree starts at the top and asks about their age. If they're under 30, okay, the next question is about whether they're a student. But if they're over 40, it asks about their credit rating instead. See how each path leads you to a final prediction, a simple yes or no? Okay, to really get this, we got to know the parts of the tree, its anatomy. So that very first question, the one about age, that's called the root node. All those follow-up questions, those are the internal nodes. The lines that connect everything, those are the branches. They're basically the answers to the questions. And then at the very end, those final yes or no answers, we call those the leaf nodes. That's the computer's final call. All right, so we know what it is. Now let's get into the how. We're actually going to build a simple decision tree right here, from scratch, to solve a really classic problem. So here's our mission, our puzzle for today. Can we teach a computer to decide if it's a good day to play tennis? The only thing the computer gets to see is some past data, just a history of the weather on days when people either did play or didn't. And here it is. This is the evidence we're giving our little computer brain. It's just data from 14 different days. For every one of those days, we know the weather outlook, the temperature, the humidity, and if it was windy. And of course, the most important part, the final answer. Did they play tennis or not? This table, this is everything our algorithm has to work with. This is its entire world. Okay, so this brings us to the really magical part. With all those different columns of data, outlook, temp, humidity, wind, how in the world does the computer figure out where to even start? How does it find that one single most powerful question to ask first? I mean, think about it for a second. Should the first question be about the temperature, or maybe the wind, or humidity? Getting that first question right is absolutely crucial for building a good tree. So how does it choose? Well, the answer, not surprisingly, is a little bit of math. The algorithm calculates a score for every single attribute. It's technically called information gain, but honestly, the best way to think about it is as a clarity score. It's basically a number that tells us how well a question splits up all our messy, jumbled data into clean, predictable groups. The higher the clarity score, the better the question. And here are the results. The computer went ahead, it crunched all the numbers, and it gave each one of our attributes its very own clarity score. It figured out the predictive power for asking about outlook, about temperature, humidity, and wind, and it ranked them from the most useful question to the least. Now, one of these numbers really jumps out, doesn't it? 0.2464. That is the highest score of the bunch. And that score, it points us directly to the one question that's going to give us the most bang for our buck, the most clarity, right at the very beginning. And that score belongs to Outlook. That's our winner. The algorithm has officially decided that the single best, most effective question to start with is, hey, what's the outlook today? So that's it. That's going to be the root node of our tree. Okay, we've got our first question. Now let's see how this actually starts to build our tree. Let's look at what that very first split in the data looks like. And here you go, it's perfect. Just by asking about the outlook, we've split our 14 days of data into 3 neat little piles, all the sunny days together, all the overcast days, and all the rainy days. Suddenly, our problem is way, way simpler. But hang on, look closer at that middle branch, the overcast one. Every single time the outlook was overcast, the answer was yes, they played tennis. We're done. We don't need to ask any more questions for that group. It's already a final answer, a leaf node. That is the power of finding the best possible question right at the start. Okay, so the tennis example is pretty simple, right? But this exact same logic is being used right now to solve some incredibly complex real-world problems. It's happening every single day. I mean, this logic scales up to solve huge, important problems. You've got doctors using decision trees to help diagnose patients based on their symptoms. Banks use them to figure out if someone is a good or bad risk for a loan. Marketing teams use them to find the customers who are most likely to buy something. Even factories use them to spot tiny defects on an assembly line. The applications are, well, they're everywhere. So yeah, from something as silly as choosing an emoji to something as serious as diagnosing a disease, the Humble Decision Tree is a super fundamental tool. It helps machines make sense of our really complex world, one simple question at a time. And that kind of leaves us with one big question, right? What are we going to ask them to decide for us next?